The role of supernovae in element creation. Supernovae, the explosive deaths of massive stars, are responsible for creating many of the heavy elements found in the universe. These cataclysmic events produce temperatures and pressures so extreme that nuclear fusion can occur, synthesizing elements heavier than iron. Stellar nucleosynthesis before supernova. Before a supernova, stars generate elements through fusion in their cores, starting with hydrogen and progressing to helium, carbon, oxygen, and up to iron. However, once a star's core reaches iron, fusion halts because iron fusion consumes energy rather than releasing it, signaling the star's impending collapse. The explosion and extreme conditions. During a supernova, the core of a dying star collapses under its own gravity, causing an explosive shockwave. This shockwave generates temperatures and pressures high enough to trigger rapid neutron capture, a process that allows the formation of heavier elements such as gold, uranium, and platinum. Neutron capture process in supernovae. In the chaotic environment of a supernova, atoms capture neutrons at an accelerated rate, forming unstable nuclei. These nuclei undergo a process known as beta decay, where they transform into heavier elements. This rapid neutron capture is called the R process and is responsible for creating many of the universe's heaviest elements. The R process. Rapid neutron capture. The R process occurs when neutrons are added to atomic nuclei at such a rapid pace that the nuclei cannot decay quickly enough. This results in the formation of very heavy elements. Elements like gold, platinum, and uranium are primarily created through this process during supernova explosions. The energy release and element distribution. The energy released by a supernova explosion is immense, and as it expands, it disperses newly created elements into space. These elements become part of the interstellar medium, enriching the gas and dust clouds that will eventually form new stars and planetary systems, continuing the cycle of element creation. The creation of elements heavier than iron. While stars produce elements up to iron through fusion, elements heavier than iron require additional energy to form. Supernovae provide this energy, as the intense conditions allow for the synthesis of these heavier elements through neutron capture and subsequent fusion processes. Enrichment of the universe with heavy elements. The material ejected by supernovae is crucial to the formation of planets, life, and future generations of stars. The heavy elements scattered by these explosions enrich the galaxy, providing the building blocks for planets like Earth, as well as the elements necessary for life as we know it. Supernovae and the cycle of matter. Supernovae play a central role in the cosmic recycling process. After they expel heavy elements into space, these elements mix with other gases and dust, eventually forming new stars and planets. This cycle ensures that the universe remains rich in a wide variety of elements, allowing for the creation of diverse planetary systems. The lasting legacy of supernovae. The heavy elements created by supernovae are integral to the existence of life and the formation of complex systems. Without the violent deaths of these massive stars, the universe would lack many of the elements necessary for life, making supernovae essential to the chemical evolution of the cosmos.